How do planes fly? And what is this Bernoulli effect? I have your answer, and I'll help you understand both right now. To understand both how planes fly and the Bernoulli effect, we first have to understand some fundamentals regarding how fluids work. And yes, in physics, air is a fluid. Take this balloon, for instance. When you fill it up, the air inside is colliding with the sides of the balloon, so creating pressure which make it expand. So if you have the air inside the balloon has pressure from molecules in all different directions. But say you take that same region of air and it's moving, what happens with that is that you have the same region and more of the molecules are moving in one direction with very few going in the other direction. Right? So then the pressure on those sides becomes very low as it moves that way. When we talk about still air, that means that the molecules in the air are still moving. They're just all moving in random directions. But when you have wind, what's happening is that the movement of the molecules is aligning with each other, all going in one direction, or more going in one direction than all the other directions. So when we're looking at Bernoulli's effect, as wind speed goes up, the pressure that they apply in other directions goes down because all the molecules are aligned going in one direction. More of the molecules are moving in the direction of the wind than in any other direction. There's still some going in other directions, creating a small amount of pressure while the wind goes in that one direction. The faster the wind speed, the more the molecules are all aligned and moving in one direction, which means that there's less molecules that are going the perpendicular directions or any other direction. So when we look at the Bernoulli effect, so with Bernoulli's equation, that pressure plus the energy from the motion of the particles with no speed has to equal that pressure plus the energy from the movement of the particles if they're all moving in the same direction. So as the speed goes up, the pressure is going to go down. Right? So the faster speed you have in one direction, the pressure on these sides is going to become lower and lower and lower. When we look at a wing, there's a whole bunch of different styles and shapes of wings. The general shape that we usually look at looks kind of like a teardrop, but sideways. So when air comes and hits this, you have some air coming down, you have other air that curves up and around, right? So when the air comes and goes above it, so looking at the Bernoulli effect, as the air comes through to the wing, and then the air that gets directed above the wing starts going faster. Well, if it's moving faster, it's fewer of the molecules are hitting the top of this wing, making it a lower pressure. Then the lower pressure than the molecules on the bottom are provided. So with that difference in pressure, you have a small amount of pressure on top, but a slightly larger amount of pressure on the bottom. So the net pressure, when you have air going over that wing, makes it go upward. But that's not the only thing that makes the wing go up. Right? You have that pressure difference, but there's also the idea that the air here is following the curvature of the wing, and when it leaves that wing, it's directed downward. And with Newton's third law, when you have a force in one direction, in this case a force on the air causing it to go downward, that means that there's a force on the wing causing it to go upward. All right, action-reaction with Newton's third law. So both the underside of the wing and the upper side of the wing are causing the air in this case to be directed downward. So both the top and the bottom contribute to an upward push or lift onto the wing of the aircraft. So two main factors when creating lift are the shape of the wing and the angle of attack. Right? Airplane wings come in many different shapes and sizes. You have a whole range of different planes, from aerial acrobatic planes to commercial jetliners to jets to supersonic jets. Each of them are going to have a different style of wing shape because of the different maneuvers they want to be making. But the other factor that can create lift is what's called the angle of attack. Because the wing itself doesn't have to be angled like this. You could take and turn the plane so that the wing is more like this. Right? As they take off from the runway, you'll see that the plane actually tilts upward so the nose of the plane is up. But the airflow is still coming in this direction. Right? So then the air that comes and hits here still goes down under and is directed down. The air that comes here still has to go up and over and comes down. Right? The big difference is that you get a much larger amount of drag, but you also get a much different lift. In one sense, there's a much larger turn to the air, right? So that causes a much higher lift, but it also causes a higher drag, which when you're already in the air flying, you want to reduce the amount of drag as much as possible, which is where you fly with it oriented with a fairly low angle of attack. But as you go to take off, you're actually going to tilt the wing so that you have a higher angle of attack. That gives more lift to the plane, while also creating more drag. So one neat thing about modern planes is that they actually have built the ability to change the shape of their wings during flight. So when they go to take off, their wings have sections that will extend and change the shape of the wing so that they get more lift even at the low speed, so that they can take off. And then as they get up to speed and up to cruising, they'll actually pull those flaps in order to reduce the drag. Aerial stunt planes are usually built with symmetrical wings so that they can flip upside down and still be getting lift just by the angle of attack of their wing. But that's how you can have a plane flip upside down and still be flying, is because they'll adjust their angle of attack so that they still get lift and are still in flight. Two main factors that affect the lift of a plane are the shape of the wing and the angle of attack. The shape of the wing can go from just looking like a teardrop to looking like kind of a bent C. There's a whole bunch of different shapes that airplane wings can be. Modern planes even have the ability to change the shape of their wing during flight, so they can have it so they can have a wing that has a big curve to it to provide more lift during liftoff, during liftoff and landings. They extend the flaps of the wings so that they have so they get a greater lift for the speed that they're going. But when they're up and cruising, they want to have less drag, because that extended flap creates a lot of drag, even though it also creates a lot of lift. So to reduce drag during flight, they make the shape of their wing more like a teardrop than a curved C. Aerial stunt planes actually have a symmetrical shape to it, just like a teardrop, so that they can fly upside down. They can flip upside down and still be flying, just based on angling the plane so that they still have a good angle of attack. Angle of attack is the angle between the wing and the airflow. So as you increase that angle, you get more lift, but you also get more drag. And there does get a point where you end up having too much of an angle, and the air going over the top stops providing the lift that it otherwise does, which is where you get planes to stall out. Right? So you can only have an angle of attack up so high before it stops providing as much lift as it otherwise would. You can experience this yourself if you stick your hand out a car window that you're riding in. I do stress riding. Don't do this while you're driving. If you start with your hand flat, as you drive and you turn it up, as you increase the angle of your hand relative to the ground, you'll notice that the air starts pushing it upward. And as you get further and further to your hand being vertical, you'll note that the air starts pushing your hand backward more than it's lifting it up. One other aspect to think of regarding how planes fly is the fact that after the air goes over the wing, the air is actually moving in a more downward direction, which means that the wing applied a force to the air, making it go downward. And by Newton's third law, every action has an equal and opposite reaction. The air applied a force upward to the wing. Because if the wing is making the air go downward, the air is making the wing go upward. Alright? So that's another aspect of the lift that's being caused, is that action-reaction from Newton's law. From the fact that the air is going downward after it goes over the wing. You'll notice that your hand